Okay, we're going to go ahead and take some notes over lessons 5.3 and 5.5. Once again, we started these in class, and a lot of you may have finished this out by reading in your book and may already have a lot of these answers written down. And so if you need to skip past this part of the video, go ahead, or if you decide you don't need to finish watching the video, that's up to you. But you might want to just be very careful. If you have any questions about any of the examples, watch the video so you're making sure you're not missing anything. Okay, so in 5.3, we're talking about applying inequalities in one triangle. That's what we're going to start off with. Remember, inequalities are like less than or greater than. And we have these relationships based on angle measures that also inform us about the relationships of sides. So if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. And in fact, we could say the largest angle, the biggest one, is across from the longest side. The smallest angle is across from the shortest side, and then that leaves one in between. And so you guys have probably already done this part, but let's just review what answers you got for 1, 2, and 3. Okay, so you can tell that UT is the shortest side, and that ST is the next longest side, and the longest of all three is SU. And so those sides are opposite the angles in the same order. So UT is opposite side S, so S is the smallest angle. And then U is opposite ST, so that one comes next. And the longest side, SU, is opposite angle T, so that's the largest angle. And make sure you pay attention. We go from smallest to largest. Okay? Number 2, we are writing the sides in order from shortest to longest. Now they only give you 2 of the angle measures, but remember, all 3 angles add up to 180 degrees, so we can easily find this angle measure for S, which is also 43 degrees. Now that means angles S and U are congruent to each other, and so it doesn't matter which one you put first for these sides, because since these are congruent angles, UT and ST are congruent sides. All right, so UT and ST are the 2 shorter sides, and then the third longest side is SU, because it is across from the biggest angle. And then in example 3, we have a right triangle where angle A measures 42 degrees, and if I do 90 plus 42 and take that away from 180, sorry about that, we get 48. Or you could just do 90 minus 42, because you should remember that angles A and B are acute angles in a right triangle, so they have to be complementary. So these two should add up to 90 themselves. And so the biggest angle is C, which we always know the hypotenuse of a right triangle is the longest. Pay attention, we're going from longest to shortest this time. So the longest side is AB. And then the shorter of the 2 legs is across from angle A, that would be BC. And then, I'm sorry, BC comes next. AC is the middle leg, and then BC is the shortest. Sorry, I got those out of order. It's okay, mistakes happen, as long as we fix them. Okay? So again, AB is the longest, then comes AC, and then BC is the shortest. All right, on example 4. Now, in order to do this problem, we need to list the sides of the triangle from shortest to longest, and in order to find out that list, we need to know the angle measures specifically, and we can't just go off of what we assume because we're subtracting different amounts. So even though we have a larger number here, we're subtracting 2, and we're subtracting a little bit less from the 4.5x than we are from the 5x, so these could be a little bit different. So what we want to do is make sure we know how to find these angle measures specifically. You'll remember that all 3 angles add up to 180, so we can just write one big long equation, setting it equal to 180, and it should look like this. All right, and when we combine our like terms, we get this. 19.5x minus 15 equals 180. That is a 15, not a 16. Make sure you're carefully listening as you write things down. And then we solve the equation for x by adding 15 to both sides first. That means 19.5x equals 195. And when you divide by 19.5 on both sides, you get that x does in fact equal 10, but that's not the answer. The answer is going to be the list of the sides from shortest to longest, and those will correspond to the angles from least to greatest. So I'm going to plug 10 in for all of these, and we should get the following angle measures. D measures 40 degrees, F measures 42, and E measures 48. So the order of the angles from least to greatest is D, F, then E. That means that the side that is across from angle D, EF, is the shortest side, and the side that is across from angle F, DE, is in the middle, and then the longest side across from angle E is DF. And again, double check, but we are going from shortest to longest, so that's that order. Alright, so what we want to do here is to compare these pairs of sides with less than, greater than, or equal to based on the angles that we are given. And so the first thing I want us to do is to write in angle Q and angle S so we have a complete list of measurements here. So this angle up here at Q, angle RQS, is 51 degrees, and angle PSQ is also 51 degrees. So that in this triangle, if we have two congruent angles, because Q and R are both 51 degrees, then we have congruent sides that are opposite them. That makes that an isosceles triangle. So that's going to be some place where we could put an equal sign. Otherwise, these are all three different angles in triangle QPS, and so all three sides will be different. All right, so let's first look at PQ and QS. PQ and QS. We're using this triangle. PQ is across from a 51 degree angle. QS is across from a 75 degree angle. 75 is bigger than 51. So PQ is shorter than QS, or PQ is less than QS. Then looking at QS and RS. QS and RS are the two congruent sides we marked, so we can say they are equal. And then QR and RS. RS is across from a 51 degree angle, but QR is across from a 78 degree angle. That means QR has to be longer than RS, or QR is greater than RS. Okay, we're going to do the same kind of information here, but about angles. Looking at the middle letter of each one of these will tell you where that vertex is. So I want you to look at the sides that are all given to us and see if we can figure out those relationships as less than, greater than, or equal to for these three. Pause the video if you need more time, otherwise these are the answers we should get. Okay, CBE, this angle, is across from a leg measuring 7, and CEB is the vertex angle of the isosceles triangle, so that one's smaller because it's across from a side measuring 5. So CB is greater than CEB. And looking at this triangle, DCE is less than CDE. And then on number 10, angles B and C here are actually equal to each other because they are across from sides measuring 7 each. All right, that wraps up our lesson over 5.3. Now we're going to jump right into lesson 5.5 over the triangle inequality theorem. Okay, and in this we will be applying the triangle inequality to identify possible triangles and also to prove different triangular relationships. So let's look at this theorem and get ready to move on. The triangle inequality theorem states the sum of any two sides of a triangle has to be greater than the third side length. All right, and we'll look at why this exists the way it does tomorrow, but in this example, if I were to add A and B, that would have to be more than C for it to be a triangle. If I were to add A and C, or C and A, that has to be more than B, and the same thing for these two. B and C have to be more than side A. When you start to apply this with real numbers, though, here's what you're going to notice. We don't have to check all three of these relationships to see if they're true. We're just going to have to pick out one. So in order for three sides to be the sides of a triangle, any two have to always add up to more than the third. So if I just take these two at a time, 8 and 5, those are both already bigger than 3, so if I add them, that will definitely work. I don't really have to check that. 8 and 3, 8 is already bigger than 5, so if I add 3 more to it, it's still bigger than 5, so that one works. But the important one, the really only one we need to check, are these smaller two compared to the third. 3 plus 5 is not greater than 8. 3 plus 5 equals 8. And since they are equal to each other, not greater than, this is not a triangle. Okay, this would have to be greater than. 3 plus 5 would have to be greater than 8, and that's not true. So once again, you only have to check the two smaller ones against the third one. In this case, 11 plus 15 is 26. That is greater than 21. Since 26 is greater than 21, yes, this is a triangle. Those could be sides of a triangle, but that's how you can answer it. All right? Now, if I have three sides that are all the same, that should be able to be a triangle because they would be an equilateral triangle, but you just check two of them compared to one. 11 plus 11 is greater than 11. That's 22. So yes, that's a triangle. But here's where it comes to get a little bit more tricky. Now we have expressions involving a variable, but don't worry, they give you what number to use for the variable, so we're just going to plug those in. 6 plus 8 is 14. 3 times 6 plus 5, 3 times 6 is 18. 18 plus 5 is 23. And then 4 times 6 minus 11. 4 times 6 is 24. Minus 11 is 13. So I want to check those sides to make sure they add up to more than the longest side. 14 plus 13 is 27. 27 is greater than 23. So yes, this is a triangle. All right, the only one that didn't work as a triangle is when these two equaled that, and obviously if we had something else like 3, 4, and 8, 3 plus 4 is 7, that is less than 8, that's not a triangle either. Okay, that's an extra example. All right? All right, on these next examples, we're not going to go through every single one of these because we're going to go through some more of this in class, but I am going to help you start by looking at how to do one. All right, if I give you two possible lengths, we should be able to come up with a range of possible lengths for the third side. Now, there are several cases we could try. I'm going to call the third side, or third length, x. Okay, so I'm going to use 4, 19, and x. Now, x could be somewhere between 4 and 19, or x could be the longest side. In that case, we could also have x over here less than 4, but that's probably not going to work. Anything less than 4 when you add it isn't going to be bigger than 19. But I'm going to show you all three cases and show you which one we never have to worry about. So first we're going to try 4 plus 19. I know that 4 plus 19 has to be greater than x. Any two sides should add up to more than the third. So when I add these, 4 plus 19 is 23. 23 should be greater than x, and if you remember how to work with inequalities, we have to flip that around. That means x can be no more than 23. In fact, it can't equal 23 either. X has to be less than 23. Okay. Now, I could say that x is somewhere between 4 and 19, some length in between them. So I would say 4 plus x has to be greater than 19. So I should subtract 4 from both sides there this time. And x is greater than 15. So that's the lowest possibility it could be. And so those two inequalities are how we would write that for now. Okay, x has to be somewhere between 15 and 23. The third case I will show you is if we did this the other way around. If I said x plus 19 is greater than 4. I'm going to show you why this doesn't work. If I subtract 19 from both sides, x is greater than negative 15. Well, we cannot have a negative side length. Can't have length that's negative. It doesn't exist. So we don't need that one. These are the only two that matter. All right, we're going to do the rest of these examples in class on Tuesday. So make sure you bring this back to be able to go over this with us. And then there are some thinking questions that I want you to answer before you come into class. And we'll talk about the answers in class. In each of these statements, there are two statements that contradict each other. So out of these three, two of them contradict each other. I want you to circle the two. And out of these three statements, two of them contradict each other. Circle those two. And same thing for number 11. All right, and we will talk about those in class on Tuesday.